Hello, I'm Karen G, reporting from JKC News Station. What do you think of when you hear vertical forest? This? Think again. This week's story. Imagine walking through an urban area. Out of the corner of your eye, you see something green where a building should be. A new project in Italy may lead the way to greenery in an urban setting growing up, not out. Vertical forest. 2 buildings have been built in Milan, housing 730 trees, 5,000 shrubs, and 11,000 floral plants. These buildings boast a variety of features that makes them environmentally friendly, including a multitude of plants, solar panels, and a sustainable irrigation system. There are many benefits to having so many plants around the building. It dampens noise pollution, provides new habitats for animals, regulates humidity, and absorbs CO2 from the environment. In addition, the presence of so many plants can reduce the amount of heating and AC used in the building. How so, you may ask? In the summer, the trees provide shade and absorb heat. Did you know that the net cooling of a tree is the same as 10 room-sized air conditioners running for 20 hours? In the winter, the trees serve as a windbreak and trap heat. Together, the 2 towers contain 400 households, and the trees can reduce 135 tons of CO2 used for air conditioning and 191 to 477 tons of CO2 used for heating in a year. Amazing! Let's hear from some experts on the science behind these buildings.
One of the most important parts of this type of building is the plant life that surrounds it. The plants offer many benefits. The 730 trees around the vertical forest absorb 17.5 tons of CO2 and releases 49,000 kilograms of oxygen per year. That's the amount of oxygen that 400 people breathe yearly. This is all done through a process called photosynthesis. Photosynthesis transforms energy from the sun into chemical energy that the plants can use. And the overall reaction includes water, carbon dioxide, and sunlight to produce oxygen and glucose. The actual process is a bit more complex and can be broken up into 2 stages, the light-dependent and light-independent reactions. The light-dependent reaction happens in the folded innermost membrane of the chloroplast, the thylakoid membrane. It all starts when sunlight hits a protein complex, photosystem II. Photosystem II has proteins, lipids, and chlorophyll. When a photon hits the chlorophyll, an electron gets excited, and this excited electron gets carried away by a mobile electron carrier. Then photosystem II does something that is quite amazing. It takes water and breaks it into oxygen and hydronium ions in a process called hydrolysis. Then it takes the electrons from this oxidation of water and replenishes photosystem II. The mobile electron carrier takes the electrons from photosystem II to the cytochrome complex. This complex serves 2 purposes: to act as an intermediate between the 2 photosystems and to pump protons into the thylakoid membrane. If you recall, hydronium ions, which are just protons, are being produced during hydrolysis as well. So when all these positively charged protons are stuck together in the thylakoid membrane, they want to get as far away from each other as possible. However, it is not possible for them to diffuse through the membrane, as phospholipid bilayers maintain a great concentration gradient. So in order to diffuse, they have to go through an enzyme called ATP synthase. As they go through the enzyme, ATP is produced. And ATP is a way to store chemical energy, but it is not good for long-term storage, so the process must go on. Now, going back to the photosystems. Photosystem I works in much the same way as photosystem II. Sunlight hits the chlorophyll, and electrons get excited, then get carried away by mobile electron carriers. However, these electrons are replenished by those that come from photosystem II. And all the energy from photosystem I goes into creating an ADPH. That happens with an enzyme, FNR, which takes an ADP plus 2 electrons and 1 proton to make an ADPH. The next stage of photosynthesis, the light-independent reaction, happens in what is known as the Kelvin cycle. The Kelvin cycle starts with CO2 from the atmosphere and ribulose biphosphate, or RUBP. An enzyme, Rubisco, combines these 2 to make a very unstable 6-carbon sugar. To become more stable, this then breaks down into 2 molecules of 3-phosphoglycerate. With the help of some enzymes, ATP gives a phosphate group and NADPH gives an electron to the phosphoglycerate, making glyceraldehyde 3-phosphate, or G3P. G3P is used by plants to make any kind of carbohydrate and is thus known as the ultimate product of photosynthesis. However, we are not done, because since this is a cycle, we have to go back to what we started with, RUBP. For every 3 RUBP the cycle started with, there are 6 G3P that are made. One is allowed to leave the cycle to become some carbohydrate and the other 5 are turned back into RUBP with the help of some enzymes and ATP. Another form of energy that these vertical forests use is solar energy. This energy process begins within the solar panel in the photovoltaic cells. These cells are surrounded by a semi-metal conductor. This metal is usually silicon. While generating electricity, an electric field is formed. This is formed by applying different elements, creating separate opposite charges on different layers. On the top layer, phosphorus is applied, creating a negative charge. On the bottom layer, boron is applied, creating a positive charge. This results in a junction between the 2 layers. So when a photon of light strikes a solar panel, an electron will pop off and be transferred into wires forming current. However, the current that is formed is direct current, or DC. In order for it to be applicable for households, it needs to become alternating current, AC. The difference between AC and DC is the direction at which they move. DC moves in a constant straight line. The graph of DC is a straight line. However, AC can move in either direction. The graph of AC is a sine wave. So in order to make this conversion, you have to use a device called an inverter. Now let's look at a basic case of an inverter before we look into the one that the vertical forests use. Within an inverter, the current will reach something called a transformer, which will harness the current inside of a coil. However, in order to make sure that is AC, you need to form a magnetic field that will move the current in opposite directions. This magnetic field is usually established using a mechanism that will switch the current in opposite directions, forming this. This case, however, makes a square wave. A square wave is not a very effective wave. A more effective wave is a sine wave. More advanced technology is needed in order to form a sine wave. Now, let's look at the inverter that the vertical forests use. The vertical forests use a grid tie inverter that produces sine waves. Now, in order to make a great output of sine waves, you need to have a good enough input of sine waves. This is done by once the DC enters through the current, it will go through an oscillator that will produce sine waves and make it AC. However, once it goes through the oscillator, the current is not strong enough to power the main coil of the inverter. In order to make the current strong enough, it goes through an amplifier. This ensures that the current will be strong enough to keep creating AC. Once the conversion is complete, the inverter will take any unused energy and store it onto the national grid. This is done by matching the different phases of the sine waves together. So if one part of the wave goes upward like this, then it'll try and line it up the same way by also making it upward. So solar panels actually generate a lot of energy for families. As of 2014, the average US household uses about 10,932 kilowatt hours per year. And currently in Milan, there are 500 square meters of solar panels. And these solar panels generate around 142,500 kilowatt hours per year to 190,000 kilowatt hours per year. Now, for future projects such as the one that they're creating in China, it would generate about 203,025 to 270,700 kilowatt hours per year. And if this were applied to other polluted cities such as LA, it would generate about 243,450 kilowatt hours per year to 324,600 kilowatt hours per year. As you can see, it generates a lot of electricity for families and would be able to sustain a lot of families.
Plants require lots of water.
Luckily, this building has incorporated a gray water irrigation system. But before we can talk about gray water irrigation, let's discuss what exactly gray water is. There are 2 types of wastewater, gray water and black water. Black water is wastewater that contains feces, in other words, water from the toilet. This water cannot be reused and goes directly to the sewage system. Gray water, on the other hand, does not contain feces but may contain traces of dirt, hair, grease, and household cleaning products. This is water from sinks, showers, washing dishes, and even the laundry machine. When treated properly, this can be reused for irrigation water, toilet water, and water for the laundry. So, how does the vertical forest in Milan use gray water for irrigation? Well, the gray water irrigation system looks something like this. As you can see, once the gray water is produced, it is sent to a surge tank, which acts as a storage reservoir for the water. The surge tank is connected to a sewage system in case of overflow of the water, but otherwise, the water is held there for a brief amount of time until it goes through a treatment system. Treatment of gray water includes flotation, filtration, and settlement of solids,
which helps get rid of unwanted solids as well as prevent clogging of the pipes. UV or chemical disinfection is used to kill harmful bacteria, and digestion of other unwanted solids is done through anaerobic or aerobic microorganisms. This water is then pumped to the plants through a subsurface drip irrigation system. This irrigation system includes running tubes called drip lines, which go underneath the plants. The water is then dripped through small holes and applied directly to the root of the plants. As a result, very little water is used, making subsurface drip irrigation very effective. Any excess gray water that is used is then sent back to the surge tank where the cycle repeats.
Gray water systems are very environmentally friendly and have the potential to save up to 60% of household water use. Considering that the average American family uses about 400 gallons of water per day, the vertical forest has the potential to save a whopping 35 million gallons of water per year. Wow.
Despite all the advantages of these buildings, critics still have concerns about safety with the risk of falling branches, harsh weather conditions for the plants, and accessibility of gray water compatible cleaning products. The choice of material used in the buildings has also been attacked, with many pointing out that while the vegetation on the building absorbs CO2, the production of the concrete used in the buildings emits a significant amount of greenhouse gases. We'll be back after this break to continue discussing vertical forests. Are you sick of taking care of your delicate balcony plants which have trouble surviving that far from the ground? Are you tired of constantly worrying that your heavy, dangerous plants will fall and injure someone? Well, don't worry, we've got a solution for you. Introducing our all-new balcony-safe plastic plants. Unlike traditional plants, which may succumb to the harsh weather at higher altitudes, our plants will never go limp or die off. Not into flowers? Well, we've got you covered with our life-size, lifelike plastic trees. With these trees, you can have your own personal forest without worrying about injuries from fallen limbs.
I was walking down the street and a tree fell on me.
Now I know what you're thinking. I live on the 20th floor. The wind up here destroys my real plants. These plastic things would just fly away. Well, they come with anchoring systems. These plastic plants do not require care or commitment. They are free of the hassle involved with traditional plants. If you want to live this annoyance-free life, call 1-800-NON-TREE or visit our website, www.toolazyforrealplants.com. Have you tried many laundry detergents that just don't work? They claim to be good for the environment but really just take your money? Buy Tide today. Compared to other laundry detergents, such as gray water compatible ones, Tide removes stains more efficiently. The gray water efficient one, Austin's Gray Water, also costs an outrageous $20 more. It doesn't work, it's just called eco-friendly as a way to take your money. I mean, you could buy one more bulk size of Tide with those $20 and have more laundry detergent. Do you really want to use dirty water to clean your clothes anyway? Call 1-800-NO-AUSTIN or visit us at www.noaustingraywater.com.
These buildings weren't cheap to build, with the total coming in at around $73 million to construct both buildings, including the special features such as the irrigation system and the solar panels. Surprisingly though, the cost of the trees constituted only about 5% of this cost. Other costs include maintenance of the gray water irrigation system, which would cost about $200 yearly, and the additional yearly cost of purchasing gray water compatible cleaning products instead of the common gray water incompatible cleaning products. And by comparing the leading brands of cleaning products as shown by this table, we calculated this cost to be around $236 per year. However, much more money is saved yearly than is used. Considering that the average price of water in the US is about $1.50 for every 1,000 gallons, with the gray water system saving 35,040,000 gallons per year, 1 year of the gray water irrigation system can save about $52,560 per year. Additional money is saved on the reduction of air conditioning and heating use, and since the average CO2 emission from electricity generation is about 1.91 pounds per kilowatt hour, and the vertical forest can reduce 135 tons of CO2 for air conditioning and 191 to 477.2 tons of CO2 for heating, with the average retail price of electricity in the US at 10.45 cents per kilowatt hour, the vertical forest can save $35,672 to $66,989 on air conditioning and heating yearly. Money is also saved through the use of solar panels, which reduces energy bills. With the average annual electricity consumption for an American household at 10,932 kilowatt hours, the vertical forest would consume about 4,372,800 kilowatt hours per year. However, the solar panels can produce from 142,500 kilowatt hours per year in Milan to 324,600 kilowatt hours per year if the vertical forest were to be constructed in, let's say, LA, translating to savings of approximately $14,891 to $33,920 per year, depending on the location. Therefore, in terms of money, the vertical forest would save about $102,687 per year, making the payback time around 711 years. This is a long time. However, it is important to consider that ordinary buildings do not pay for themselves over time, and that the savings due to improved human health from cleaner air have not been factored in. Because the vertical forest is a green building, a better way to evaluate it would be to assess the environmental costs and benefits, specifically the reduction and production of CO2. Opponents of the vertical forest frequently cite the production of CO2 due to the use of concrete as a major disadvantage. 9,000 cubic meters of concrete, which is about 23,873 tons of concrete, are used in constructing the vertical forest in Milan, and producing a ton of concrete generates about 0.9 tons of CO2, giving a total of about 21,486 tons of CO2 produced. However, concrete is special in that in concrete's lifetime, between 33% and 57% of the CO2 emitted will be reabsorbed through a process called carbonation. So the net CO2 production of constructing the vertical forest is in reality about 9,239 to 14,395 tons. However, the vertical forest absorbs more CO2 in the long run than it produces. First, trees can absorb up to 48 pounds of CO2 per year, so the vertical forest absorbs about 17.5 tons of CO2 yearly. Second, as mentioned before, the trees on the vertical forest reduce air conditioning and heating use. In a year, the trees can reduce 135 tons of CO2 for air conditioning, and from 191 to 477 tons of CO2 for heating. Third, the use of solar panels reduces the need for fossil fuels, which emit CO2. With this average CO2 emission from most common sources of electricity at 1.91 pounds per kilowatt hour, solar panels can reduce CO2 emissions by 129 to 295 tons per year. So in total, the vertical forest reduces CO2 by 472.5 to 801.7 tons per year, making the payback time in terms of CO2 only 11.5 to 30.5 years.
Yes, thank you to all the experts who joined us on the show today. We certainly learned quite a bit about vertical forests. This topic is growing and becoming more important to our future. The vertical forest in Milan won the International High Rise Award in 2014, and the growing support has allowed for plans to build similar buildings around the world, a hotel in China, and a residential building in Switzerland. Not only are these buildings environmentally friendly, but putting greenery in urban areas encourages learning, inquisitiveness, and alertness. Until next time, this has been Karen G with JKC News. Have a good evening and good night. And set it.
No. Oh, that's wrong.
So,
The search tank. See, this is well.
Third. Oh, I can't do it.
so
The necessity for care or a commitment. 1-800-NO-AUSTIN.com. What?
I forgot. Because I just did it.